So here we're looking at the second derivative. We did a bit of work about, and that was f double dash of x. F double dash of x can help us with a few things. First of all, it can tell us whether something's a stationary point is a maximum one, which we did a bit of work last time. So it was a max f double dash of x is less than 0, and a minimum if f double dash of x is greater than 0. It also can help us to find things called points of inflection. And I'll explain what those are. So if we've got a graph here, for example, we've got a cubic. Point of inflection here is not where the gradient is 0, but it changes from what we call, this is called concave down. And it's sort of when you hold your hand upside down, and it's sort of the shape that your hand makes. And conversely, we've got concave up. Is where you turn your hand upside down, up the right way, and this is what concave like. So it's where the graph kind of changes direction a little bit, and a point of inflection is where f double dash equals 0. Okay, so if we look here, we've got our maximum, and we know at that point that f double dash is less than 0. So for anything concave down, how we find it, we find f double dash is less than 0. And conversely, for the concave up, f double dash is greater than 0. So we can use that information. Here's a different type of graph, a little bit, so we can say where points of inflection are. So it changes here. Here it's concave down till it probably reaches about that point there. Then it changes to concave up till about that point there, and then it changes to concave down again until about here, and then it changes to concave up again. So all of those points there are our points of inflection. Okay. So if we're asked to find our points of inflection, I'll just move that up a bit. So for example, we'll find the points of inflection for, I'll just write the question out. And we're finding them for the graph f of x equals x to the power of 4 minus 4x3 cubed plus 16x minus 2. We're not asked to find the stationary points, i.e. the max and min. We're asked to find the points of inflection. So if we've got, find f dash of x first, and that becomes 4x3 minus 12x squared plus 16, and double differentiate it to find the points of inflection. So 12x squared minus 24x. And what we do is then put that equal to 0 to find out what our points of inflection are. So we can factorize that. So pull a 12x out the front, and we've got x minus 2. So therefore, our x, because we let this bit equal 0, so that means x can be 0 or x is at 2. So we've got 2 points of inflection there. Of course, you need to find out what your y values are, so you substitute both of your x values back into the original equation. So if we've got x equals 0, f of 0 equals 0 to the power of 4 minus 4 times 0 cubed plus 16 times 0 minus 2. That gives minus 2. So that's one of our points. And then we do the same for the 2. I'll just move that up. So, okay. So f of 2 equals 2 to the power of 4 minus 4 times 2 cubed minus 16 times 2 minus 2. And that equals 14. So our second point is 2, 14. So those are our 2 points of inflection. Okay, if we have another type of question. So this is our second example. We're going to find out where this graph, just write it out, find where y equals 6x squared minus x cubed plus 15x minus 2 is concave up or concave down. Okay, so what we need to do is find the points of inflection first. Okay, so if we've got y dash is 12x minus 3x squared plus 15. And then we've got y double dash equals 12 minus 6x. Okay, so what we need to do is find the point of inflection first by putting your y double dash equal to 0. So 6x equals 12. So at x equals 2 is a point of inflection. Now, where to find that it's concave up or down, what we can do is look at points either side. So we're looking at y double dash. Okay, so we know at 2, our f double dash of x equal to 0. Okay, so let's try at 1. So if we substitute 1 into there, 12 minus 6 times 1 is positive. Okay, it doesn't matter what the value is. So we know that's positive, so that must mean it's concave up. Okay, if we look at 3, so we've got 12 minus 6 times 3. 12 minus 18 is negative, so that must mean it's concave down. Okay, so if we were to write these formally, so we know when x is less than 2, it's concave up. And when x is greater than 2, it's concave down. Okay, so that's how you do looking at concavity and what the second derivative does.